Hello everyone, this is section 4.5, dilations. Our essential question, what does it mean to dilate a figure? Well, we've got a little bit of a definition here for you. A dilation is a transformation in which a figure is enlarged or reduced with respect to a fixed point C, called the center of dilation, and a scale factor K, which is the ratio of the lengths of the corresponding sides of the image and the pre-image. That's a lot of words. That doesn't mean a lot to me. Here's what you need to know. A dilation makes something bigger or smaller. And we usually use the word figure to describe the picture. Smaller or bigger. Now, if it makes it smaller, we call it a reduction. If it makes it bigger, we call it an enlargement. Now, there's a nice formula we use to find our scale factor, because our scale factor tells us if the picture is going to get bigger or if it's going to get smaller. The formula for scale factor is K equals CP prime over CP. And that might not mean anything to you right now, but it will here in a little bit. Something else to know, if your K is between 0 and 1, we're going to get a reduction. If your K is bigger than 1, we're going to get an enlargement. So let's take a second, kind of get this written down, kind of process it, and then we're going to move on to our first example. All right, so our first example, find the scale factor of the dilation. So we're finding K. Well, K equals CP prime over CP. Well, if we look at this picture here, it looks like CP prime is 12. Makes sense to me. The distance from C to P prime is 12. And the distance from C to P is 8. There we go. We've got 12 over 8. But we want to write this as a reduced fraction. So remember, you find the biggest number you can divide 12 and 8 by. Here it just happens to be 4. So my scale factor is 3 over 2. Then I need to figure out if that's a reduction or an enlargement. Well, remember, our rule is if K is between 0 and 1, we have a reduction. If K is bigger than 1, an enlargement. Let's see. 3 over 2 is 1.5, and that's bigger than 1, so this is an enlargement, meaning our picture got bigger. Let's look at the next one. Find the scale factor. So K equals CP prime over CP. Let's see. It looks like CP prime is 18. Because the distance from C to P prime is 18. And then it looks like CP is 30. Distance from C to P is 30. Now again, we want this as a reduced fraction. Biggest number I can divide both of these by is 6, so I get 3 over 5. Now I check it out. 3 over 5 is 0.6. Well, that's between 0 and 1, so this is a reduction. We're going to get smaller if we do this dilation. Okay, so that's finding the scale factor. Now let's figure out how to use the scale factor to find a dilation. So when we're finding a dilation, essentially what we're doing is multiplying all of our points by k. That's what this slide says. Multiply all of your points by k. Now remember, k is the scale factor. So we're saying k is 2 here. So I've got A, which is 2, 1, B, 4, 1, C, 4, negative 1. And the rule says multiply all of your points by k. So I'm going to multiply everything by 2. So 4, 2, 8, 2, 8, negative 2. A prime, B prime, C prime. Now let's graph this just to see what happens. So 2, 1 is A, 4, 1 is B, and 4, negative 1 is C. Then we've got 4, 2, which is A prime, 8, 2, B prime, and 8, negative 2, C prime. So what happened? Well, it looks like our picture got bigger, which makes sense because if k is 2, this is an enlargement. So when we're trying to do a dilation, we're just going to multiply all of the points times k, and then graph it to see what happens. So that's what an enlargement does. How about a reduction? So let's see what happens here. My k is 1 over 3. So I'm going to multiply all of these points by 1 over 3. Now, when I do that, I probably will need a calculator, but luckily, by the magic of video, I can show you what all of these will equal. Ah, look at that. How exciting. We did it. Through the power of video. Now again, if you're not sure what I did, I just multiplied all of these by 1/3. Okay. Let's graph it. Let's see what happens. Now it should be a reduction, so our picture should get smaller. So we've got negative 3, 6, 0, 6, 3, 3, and negative 3, negative 3. So there's our original. Now our next one's going to be at negative 1, 2, 0, 2, 1, 1, negative 1, negative 1. And there we go. We got smaller, but our picture stayed the same. So that's what a reduction looks like. And the last one, what if we multiplied by a negative? Let's see. So again, what we're doing is we're just multiplying all of these points by negative 2. So times by negative 2, dot, 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 you get the picture. So negative 2, negative 4, negative 6, negative 2, negative 2, positive 6, P prime, Q prime, R prime. Now let's plot this. 1, 2 is P, 3, 1 is Q, and 1, negative 3 is R. P, Q, R. Now P prime is at -2, -4, -6, -2 is Q prime, and -2, 6 is R prime. So there we go. We've got our nice new picture. So it looks like it got bigger and rotated 180. So that's what happens when we get that negative. It gives us that rotation. So, key thing, multiply by your scale factor, rewrite the points, graph it, see what happens. So that's dilation. It's kind of a big deal. See you next time.